So this will be the first lecture on energy management. So this is a 2 credit module. I have shown you last time the detailed syllabus or module descriptor. So we'll see the first topic on this. So I'm trying to get an introduction to energy management, why we need to manage energy. So one of the many burning reasons is when we need energy for our day-to-day uses, for example, even conducting this lecture to have electricity, but to generate electricity, we might be burning fossil fuel or etc. So with that, CO2 will be emitted, carbon dioxide, and maybe transportation with cars, industries, etc. So with CO2, there are so many adverse effects to the environment. So that's why we need to control it, manage it. So this is a summary of why it's important to manage energy in buildings. So you can see the cost, which is that we are experiencing. The cost for your electricity, it's increasing day by day worldwide. Okay, and also all of the possibilities are taken place with the advancement of technology to reduce the consumption. For example, for lighting, to replacing some lights with LEDs if possible, like that. Okay, so there are, and furthermore, renewable energy generation. So it can be solar, it can be wind, it can be thermal. There are so many sources. Renewable energy, so less environmental pollution or environmental degradation. Okay, so this is a comparison of energy consumed. This is for a UK office I got from the uploaded reference book. So you can see the main difference is the first first view is for naturally ventilated office. Naturally ventilated means windows, doors, etc., lighting. And then the second part, air condition. So if the air conditions run, so for example, those countries, they have summer, winter, etc. That's why they have heating and hot water requirement as well. So if they run air conditioning, so you can see that for the same office, the consumption can get increased. Okay, right. So now I would say this is the key summary of energy management in buildings. So why we need energy management? So I have asked this question in exam as well. So what are the aims to minimize energy consumption? First of all, optimizing size of plant. So here, what I mentioned as plant means what? So that is can be an equipment, for example, a boiler, air conditioner, okay, generator, etc. Then maximize the energy efficiency. So efficiency means output, how much we output for a given input. So increase the output as much as possible. So increasing the output or efficiency will reduce the waste. And finally, reducing carbon emissions, and most sensible answer is to reduce the cost. So energy management achieved by, there are like 4 key criteria that we can follow. First of all, we have to measure or estimate the ongoing energy consumption. Then we have to give recommendations. So look at suitable solutions, how to improve the energy usage. And then not only improvement, but we need to have a mechanism, strategy to maintain that improvement. So maybe not just 1 month. So how we maintain this for 6 months, 1 year, etc. Okay, so there should be a plan, implementation in place. And so all over target is to reduce or reducing energy consumption. We'll discuss the details in the coming segments. So there's another aspect of green building will comes into play as well. So green building that is another key mechanism to improve the energy efficiency. So it means how we can use as much as naturally available renewable mechanisms rather than using fossil fuel burned energy, electricity, etc. Uh, for our day-to-day work like offices, houses, etc. Okay. Okay. So uh, green building concept. So we don't need to discuss this much. And the other possibility or another mechanism to achieve energy efficiency or good energy management is with legislation. It means with laws, regulations. So one of the used mechanism is like code of practice for energy efficient building. So let's say if you want to make our Faculty of Technology building a green building, energy efficient building. So what sort of solutions that we can take, maybe during the construction process, after the construction, even when you are studying there, how to make this uh, building more energy efficient. Okay. So we have a topic comes up in the last topic, legislation and policies. We'll discuss there. So if you look at the website of Ministry of Energy and Power, so they publish a lot of resources uh, in order to show what's our consumption. For example, here, this is a summary of electricity generation. So what are the sources they are using? Hydro, thermal, coal, etc. Okay. So then thermal coal, thermal CEB or IPP. So there are then renewable energy like mini hydro, wind, solar, biomass, etc. So we call this an energy mix. So we use a mix of energy sources to achieve the requirement. So then not only that, Ministry of Energy, so they publish the daily consumption information. For example, you can see hourly, time to time, they publish how much energy that we are using. So you can see some plants, so they try to keep at a constant level. For example, coal and thermal oil, but hydro, they will be varying with this is for the morning peak. You can see in between 5 a.m. till up to like 6:30. And then there's an evening peak, afternoon peak. Okay. Evening peak after people coming home and how they consume energy. So how they maintain it. So we call this an energy mix. And this is something I want to discuss, cost effectiveness of energy saving measures. So cost effectiveness means whether it's effective for the money that we are spending. So let's say one example, you have 10 uh, incandescent bulbs in your house. So one incandescent bulb can be cost about like 200 rupees. Then you are planning to install or replace these with LED bulbs. But LED bulbs are expensive. Let's say one LED bulb can be like 1,000 rupees, 1,200 rupees nowadays. So if you're planning installing 10 of them, replacing 10, like nearly 10,000, 12,000. So now your capital investment is 12,000. So now you need to work out, let's say, if you ask your parents money, they will say, is this a waste? Are you, is this or beneficial for us? So then you should be able to calculate. how much energy that we will save per day or per week, per month, and based on that, that 10,000 or 12,000 investment, how soon you can recover. Okay. So not only bulbs. So for example, another case can be wall insulation. So if you want to add another insulation to a wall, or let's say replacing old generator, old air conditioner, old boiler from your factory, or like we in our assignment that we are discussing, installing a renewable energy source, for example, PV system or solar system. So would that get the benefit for that investment that you are spending? Okay, so I think this is the assignment that I have discussed last week, and we'll discuss it later as well. Now, not only educating the public about this energy saving or energy management, the government is doing some initiatives. Initiatives means they are promoting it. So they are giving some incentives. They are giving some triggering. They are giving some benefits to the public. For example, Surya Balasangram, solar rooftop program, Rivi Aruna, solar village. So they have set up few model villages in Kegol district, Polonnaruwa district, Bakamuna, Kalutara district, Bolgoda, local income villages in Ampara, etc. like that. So all over the country, they have set up several villages, installing solar rooftop power generation, so that maybe they are bit far or remote, or some cases poor families or low income households, etc. So there are so many, like nowadays, say, bank loans. So if you look at I think bank BOC also having a bank loan mechanism for solar installations. So there are several incentives, motivations for us to go towards good energy management. So now that is the introduction. Now I will move on to the buildings energy use. So there, this is the first part of the building or energy consumption. So why we need to use energy for building? For example, let's say during your training a factory, where are the energies used? Okay, so in a factory, of course, the machinery is there, but what about workers? So workers, we have to consider three comfort requirements: thermal, visual, acoustic. Thermal means temperature-wise, the temperature, humidity, etc. So we should be feel comfortable thermally, temperature-wise. Visual, it means, so since we are working, our eye should not get much strain, must not get much stress. So that is, so therefore we should have appropriate level of lighting, not like very dim light if you like reading or some signing a document or reading documents, preparing, etc. Then acoustic aspect. Acoustic comfort means sound wise, noise wise, whether you can focus and do your work. Because at the end of the day, while we managing energy, we have to make sure we get the work done. So in your factory, you cannot run that to a loss. So you need to make profit. You need to make production. So that is the main thing. While doing that, so we try to manage energy as well. So how we figure out where and how energy used in buildings, and then we will discuss about energy consumption and some of energy saving measures effectiveness. So first one is thermal comfort. So there are several terms: air temperature, radiant temperature, relative humidity, air movement. So I have asked this question in exam as well. the requirement or the specifications to be looked when we considering thermal comfort are air temperature. So the temperature around our body. Okay. So even if you have a thermometer, you can measure it. Radiant temperature. Radiant temperature means what? Radiation means so emission of heat. For example, if you have a, let's say, concrete rooftop. Now, our faculty of technology, we have concrete rooftops. So if you have lectures in the second floor, the top floor, you will see. So the rooftop get heated up, especially like in afternoon. It will be very difficult, even though we running air conditioners. You will see it's very difficult. So that is radiant heat. So the walls, the roofs, or that can be heated up. Like even some cases when we open up windows, the sunlight can come through the window and then it heat up the floor. And that once the floor get heated up, it emit heat. Then relative humidity. So relative humidity is how much humid, the moisture that we have around us. So nowadays it's bit humid because it's rainy and etc. You will see it uncomfortable. So you might need fans, etc., or open up your windows so to have good circulation. And also air movement. So we need to have a small amount of airflow. So air movement, if you don't have airflow, so then it is not comfortable as well. So now, generally, the officers maintain operative temperatures of air conditioners or air controlling systems 90 to 25 Celsius degrees Celsius. Then relative humidity 40 to 70%. Okay. And also there should be a small degree of air movement like fans or any air circulations, etc. There should be small air movement, so generally below 0.15 meters per second. Then, so these are the main requirements to achieve the thermal comfort. Also, there should be a mechanism uniformity of temperature distribution. So one example is, let's say if you have a big factory floor and you have only like 4 or 5 fans, so to get that air movement and cooling, you need to go close to the fan, away from the fan. So since that is not enough for the whole factory floor, then away from the fan, it will be very easier, very difficult to work. So the workers will not work very efficiently. So you cannot get a good output. Okay. Then the other requirement is, or the factor that you have to consider, level of activity. Level of activity means whether it's a factory floor or whether it's like a gymnasium or gym. In a gym, people need like go there, they work out, they get sweating, etc. So that time it's very difficult to maintain like a cool that, and it's not even required because say for a gym, people get to go to get sweat or to do exercises. But for an office building, government office or etc. So very not much activity. So people mostly will be sitting on desk and the public coming and going and like that. So then the activity is less. So therefore, we should be able to maintain good circulation and air temperature. So that is about the thermal comfort. Now the second one is visual comfort. Visually, for our eyes, how to get the comfortness. So I have asked in exam as well, what is visual comfort? So if you mention occupants to carry out their task without visual strain, so I'll be looking at this keyword, visual strain. So whoever the occupant has to be able to conduct their business, conduct their task, do their work, do their job without visual strain. It means without more stress to your eyes. Okay. Not only the lighting quality, but also quantity would be required. It means quality means the color of the light, the glare, etc. Okay? The quantity means rather than like some cases, maybe if you have a small room, maybe one light is, but if for a factory floor, how many lights needed? So how to cover up all the areas? And some cases, if you in like working in like IT company, etc., so they have a lot of computers, so they should be able to view this computer screen without much strain. So there should be appropriate lighting for that. And also we use lighting for safety. For example, let's say in an event of fire, the normal electricity connection get disconnected for some reason. So there should be emergency lights. So that should be guiding us how to get out of the building. So we should be able to see the exit path as well as, so then you can go out of the building safely. Then the third comfort requirement is acoustic comfort. Acoustic means noise-wise. So noise-wise, so it's very makes sense. So you should be able to conduct your business, conduct your job, conduct your work without intrusion from excessive noise. So maybe neighboring rooms or the buildings, or some cases building service equipment like fans, pumps, lifts, etc. So if they're making sound, that is also not comfortable. So one of the highlight is 70% of workers said they could be more productive in a less noisy office environment. So if the office environment is less noisy, the most of the office workers believe they could be more productive. Okay. So if so, this is something I got from ResearchGate publication. A, a typical building energy consumption for tropical countries. So Sri Lanka is a tropical country. Yeah, we get a lot of sun and monsoon rains having etc. So most of the tropical countries, since it's hot, so building more 56% of energy is used for air conditioning, 16% for lighting, 18% for equipment, and other 10%. So that depends on the type of the building. But this is a typical building. Um, now, how to calculate the energy consumption of building? So energy consumption of building, we can calculate with watts. So energy, it's calculated with the watt. So the energy measuring unit will be watt hours. So for example, if you look at your electricity meter at your home, the units are mentioned as kilowatt hour. How many kilowatt hours? So if you're using 10 units, or sorry, 60 units, 50 units, etc., 10 kilowatt hours, or 60 kilowatt hours, 100 kilowatt hours, like that. Okay. So energy consumption, we have to figure out what are the sources of energy into the building. For maybe supply, maybe if there are so many people, then their body heat and etc. That heat is also added. Sedentary work means not much heavy duty, like sitting on a desk, sitting on a chair, like you that sort of work. We may be emitting like 100 watts. Heavy manual work. So if you're lifting it, transporting it somewhere, and etc. Occupant, then it's about 400 watts. Okay. Then so to get an idea about the power consumption, so check your computer or laptop. So what's its energy use or the wattage in sleep mode, power saving mode, or some cases when the hard drive is uh, uh, reading the data or saving them. So that's about 200 watts. So check the rating of your computer or laptop. So this is some brief question that I have asked in the slide. We will discuss this during the discussion session. This is something also I want to discuss. So how we make sure, so the more suitable, are we using some efficient lighting system, efficient air conditioning system, etc. So we always measure the energy that we are using per unit area. So it makes sense, isn't it? Like if you have a small room, you may be able to light up that with one bulb, for example, simply. But if you have a bigger room, you may be needing more than one bulb. So that is, so therefore you can see there's a connection between the floor area and the energy use. So that's why even in your assignment I have asked, so check the size of your building, size of your house. And with that house, so see how much wattage that you are using for lighting. So if your house figure comes around 8 watts, so that can be efficient setup. Okay. Then computers, or like if you have an IT office or etc., where you have set of computers, so this might be a good figure, 5 to 15 watts per square meter. Okay. So there's another thing I would like to discuss here. Intermittent use. So this will be important for your assignment as well. Intermittent use means so that equipment is not used 100% work or full capacity all the time. For example, a printer. So if you have a printer in your office, maybe it's always switch on, but it doesn't run its internal mechanism, internal power always. When only they get a print job, only they start up and print it, and then again they will go to hibernation mode. So that's why based on that, so we can use, say, if the printer is 100 watts, but if the office is open 8 hours, so it doesn't mean the printer uses 100 into 800 watts. So we can say half of it, 0.5, so 400 watts, etc. So that's a usage factor to allow intermittent use. Then some mechanisms to achieve energy efficiency, more efficient and suitable light source. So this is very important. Not only efficient, but also suitable light source for the purpose. Control of operation hours. So how we arrange our hours of operation, and attitudes of occupants towards build switching off when not in use. For example, let's say you go to a lecture room, you finish the lecture, and when you leave, so whether you turn on off the lights and fans, or whether you leave them as it is, so that's the attitude of the occupants. Okay? So during this session, I would like to discuss about calculation of heat loss. So the heat loss is measured with U value. So U value is a measure of heat transfer through a building element. So let's say a wall. So this example I have considered as a thermal resistance or insulation mechanism of a particular wall. So the idea is, in order to control the heat gain to a particular building or particular room, so we should be able to figure out what are the ways that heat comes into a building. So let's say if your room has 10 people in it, so definitely that 10 people's body heat will be there. But not only that, but let's say if you're getting heavy sunlight, then that sunlight will straight away comes in, as well as it will heat up the floor, and then you will get as radiant heat. Then you have to use a lot of energy to cool down the space. So U value is the reciprocal or 1 upon of total resistance. So total resistance is calculated with resistance of inner surface, resistance of wall, and the resistance of outer surface. So I will discuss these during the discussion session. The wall can be consist of several layers, like we are discussing about insulation. Okay, so and the thickness of each layer. So we'll do some example calculation of this after the lecture today. So just to give you an idea about to get some information on how to control the energy coming in to a particular building. Okay. So answer we will discuss today as well. And the discussion was, so based on the insulation thickness, how the U value has been changed, and whether it's the question, after all, we have to discuss the cost effectiveness, how much that you are spending for this installation of insulation, new insulation or other energy saving measure, and how long, how quickly you can recover that cost. Okay. So we will discuss about this variation during the discussion. So then I will stop this recording. Oh, right.